Hello everyone, this is a hint for problem number 20 on exam number 1. I will post the full solution after the exams are all handed in. All right, let's take a look at the problem. We talked about a manufacturer manufactured or produced this many DVDs, 1,850,000. Okay. As it turns out, we don't care about that, actually. You'll see in a minute that that doesn't even come up. Okay, of these, approximately 3% were defective. Okay, and then we're going to take a random sample of n equals 170 players is drawn. You take 170 of these players out of these 1 million that were produced. Okay, and then it gives you directions here. It says, we want you to use the Poisson approximation to the binomial distribution to calculate what the probability is that fewer than 4 were defective. Well, fewer than 4 of the 170 that you selected. All right, and then there's A, B, C, D. It's multiple choice. Okay, so now bear with me here. Close this. Hang on one second. Okay, so here's my solution. Took me about how many pages? It took me 9 pages to solve this. And I'm telling you, folks, if you'll just follow my advice, you'll be glad you did. This is the level of detail that you should be doing these problems in, okay? Don't just write down answers. Don't just write down calculations. Write a book. Write a story about what's going on. And it's always the same way in mine. It's given certain information. I write down what I'm supposed to find. I write down a discussion. Typically, I'll write down, formulas. And I'll explain it, okay? So I'm going to give you a big hint here. So here's what I'm given. The total number of players, as I mentioned a moment ago, we really don't use that. We're also told that 3% are defective and n equals 170. That's what's selected. What are we supposed to find out? We're supposed to find out what's the probability that fewer than 4 of these 170 were defective. So here's my discussion. This is a binomial distribution problem. Why? Why is it a binomial distribution problem? It's because the player is either defective or it's not defective. That's the key to this problem. You have to understand that this is binomial. Defective, not defective. So P, that's the probability of being defective, that's 0.03. How do we know? It told us right here. That was our given. That's why you want to write this stuff down in this format so you can find the information you need. Q is the complement. That's where it's not defective. Well, that's 0.07. Okay? So it's a binomial distribution. What we're asking for is what's the probability less than 4? Well, if it's less than 4, that means that 0 are defective, or 1 is defective, or 2 are defective, or 3 are defective. Okay, so there's 1, 2, 3, 4. There's 4 possibilities that satisfy the requirement that it's less than 4. 0 defective, 1 defective, 2 defective, 3 defective. Well, here's the binomial formula. That's from somewhere or another, someplace or another. Hopefully you have this one memorized. You use it enough. Well, for crying out loud, you look at this, and you say, this is too hard. It's just too hard. X is the number of defective, right? So X can be 0 defective, X can be 1 defective, 2 defective, all the way up to N. It could be that all N of them are defective, all 170 or whatever it was. I can't remember scalars to save my life. Okay, so n is equal to 170. This formula is a formula we always use, and it could be, and x is the number of guys that we're interested in. So x is the number of defective. It could be 0 or defective, 1 is defective, 2 is defective, 3 defective, 4 defective, 5 defective, 6 defective, all the way up to n are defective, okay, out of the 170 that you picked. Well, good luck doing this calculation. What a headache, right? So it's too hard. So one of the ways that we can do this is we can use the Poisson distribution. It's an approximation. So the book tells you when you can use it. But the reality here is the problem tells you to do it. So this is what we're going to do. Well, here's the Poisson distribution. That's on page 291 and page 293. Here it is. So all we got to do is figure out, what do we plug in here? Well, again, x is the number of occurrences that we're interested in. Lambda is the mean number of occurrences over some interval. See page 291. Okay. Well, that's easy enough to calculate. The lambda is easy enough to calculate because it's the mean, right? Well, we know what the mean is of a binomial. A binomial distribution is n times p. The mu, the mean of a binomial distribution is n times p. That's on page 297. And I promise you, this is how I do all my problems. I write down references. I write down a little explanation of everything. You know, exams and homework are meant to be learning tools, so, you know, make the most of them. Okay, so here we have mu is therefore 170, that's how many we picked, times 0.07, so that's 5.1. So lambda, this symbol right here means therefore. So therefore lambda is equal to 5.1. So we're going to use our formula here, okay? So we want to know what's, and this is in the book, with a mean of, or I'm sorry, x is the number of guys that we're interested in, the number of guys. So like we want, what's the probability of getting 0 that are defective with a lambda of 5.1? You plug it all in. What a mess, right? It's horrible. Plug it in here. Probability of 1 with a mean of 5.1 with a lambda of 5.1. You plug that in, and it's just ridiculous. It's just horrible, horrible, horrible. That's why we have calculators. That's why we have computer programs. And well, let me finish this. Okay, so here we go. We calculate the probability of getting 0, getting 1, getting 2, getting 3. Yeah, that's it. 0, 1, 2, and 3. Okay, so we get an answer for each of those. We round them off. We add them up, and boom, we get an answer that's close enough for government work to A that's on the answer sheet. However, there's actually a couple of easier ways of doing this. There's a table that has these. I hope you've been using the table in your homework. Table C on page 781. Let's bounce down to that. Here's table C on page 781. For given lambdas, here's a lambda of 3.1, a lambda of 3.2, lambda of 3.3, and so forth. The one we're interested in is lambda of 5.1. That's what we just figured out what the mean was. So for this particular lambda, if you have an x of 0, what's the answer? 0.0061. If you have an x of 1, what's the answer? It's this one. So I can remember that in my head, my short-term memory. 61 and 3111. That's exactly what we got up here. Boom, 61.0311. Okay, so you don't have to do this calculation. You can do the table. All right. Another way of doing this, you know, this was supposed to be just a hint, but I'm actually doing the problem. Another way of doing this is to say, okay, I have a binomial distribution. It's too hard to calculate that. Let me do it using the normal distribution. So we can use the normal distribution, and we want to know what the probability is that x, that's the number of defective guys, is less than 4. So we have to use the continuity correction. Everything's explained on page 355, and here it is, okay? So here's another way of doing it using the normal distribution. Okay, well, I kind of did the problem for you, but that's okay. The purpose of this is to learn this material. I might just give everybody, if you've already handed in your problem, if you've already handed in your answer and you did it wrong, just send me an email and I'll give you credit for the problem. Okay, thanks. I got to turn this thing off here again. 1 second.